going. And that's what that first number tells you. That first number tells you how far out you're going, 2. So you're going out whatever 2 units is on there. Okay, now in terms of like you writing the correct answer down, I'll snip that part in next so that we've got it. Because it's not gonna be multiple choice in your test. You're gonna have to like draw it here. But you can see it's letter A.
Yeah, okay.
Okay, is that okay?
Yeah.
All right. I should have done these in a different order. I apologize. Let me do 4 first or next. We'll come back and do the negatives, but okay, so number 4 here, it's 2, 7 pi over 6. So my preference again, and this may not be how you see it in classroom, but my preference is always to figure out from the starting position, like where is this angle? Where is 7 pi over 6 in the unit circle? Okay, and you by now you're supposed to know it's there on the unit circle. That's 7 pi over 6 in the third quadrant. Okay, but again, it's like, well, how far out is it? The 2 tells you how far from the origin you're going out. You're going out 2 units from there. It's like taking steps. Imagine you're standing here at the origin, but you're pointed 7 pi over 6. So you step once and then you step twice, and that's where you're at.
Oh, okay.
It's a rotation followed by a walk.
Got it. Yeah, that makes sense.
Okay, now you could walk and then rotate, but I think it's easier to think of it that way. And again, in terms of your A, B, C, D, your multiple choice here, hopefully you see that you're at C for that
Yes.
one. Okay. Okay, now let's look at number 5. We'll come back and do 2 and 3, but we're trying to do the easier ones first. 2, 5 pi over 6. So again, you either draw it or you look at your unit circles, like where is that? Where's 5 pi over 6? Well, it's in the second quadrant here. There's 5 pi over 6. Okay. So then the question is, well, how far out is it? Well, you take 2 steps out. So it's right there. Letter B on your graph.
B.
Yeah.
Okay. Yeah, that makes sense.
All right, now for some more. Actually, let's do 8. 8's. We're doing the nice ones, the friendly ones, and then we'll talk about the unfriendly ones that are a little bit tougher. Okay, so 11 pi over 6. Where is that on the unit circle? It's down here in the fourth quadrant.
Right.
Okay, so there's 11 pi over 6, but then you're walking out 2 units. So I think that corresponds to, in your picture, D.
Okay.
Is this okay, or is there?
No, that makes sense.
Makes sense. Okay. All right. Now we're going to go to the ones that are more difficult. So let's go to number 3 next.
Okay.
So number 3, there is a method to this way of doing it. So forget about the -2 for a moment. Just go to the angle pi over 6. Where's pi over 6? It's right there.
Right.
Okay. So normally if it was +2, you would take 2 steps forward, right? But when it's -2, you take 2 steps backwards along that line. So this is where you actually are. This is -2, pi over 6.
But why would they put -2 when they could put just like the angle itself and then 2?
Good question. So that's where this is leading. And I'm glad you actually figured that out here as we're doing it. There are 4 ways to get to every place on the unit circle.
Fun.
And guess what you'll be asked to do on a test or a quiz?
The harder one.
Come up with all four of them. Okay.
Of course.
So it's a really good point here is okay. So let's do this. Well, we do need to answer the questions, but that is really what the core issue is, which is like, can you tell me all the ways to get to that particular point? Okay. So let's which ones have we not done yet? I'm tempted to go right into that. I think we should. Okay, let's look at letter A
Okay.
and let's talk about that. So on the unit circle here, and just make a picture here for letter A. So A is right here.
Mm-hmm.
A is at 2 comma pi over 6. Okay, so that's one way to get to it. So here's another way to get to it. What if you go backwards? Can you go backwards to get there?
You can.
Okay. So you go backwards, and then you still walk out 2.
Okay.
Sorry about that. Okay, so then there's another way to get to A. So the other way to get to A is, imagine A is actually over here in blue.
Mm-hmm.
So how do we get to that one?
The angle itself.
Yeah. Do you see how it's 7 pi over 6 to get there?
Mm-hmm.
But to get back to the original A, you have to negate it, the number.
-2. Okay.
Yes. Okay, and then the final way to get there.
Let me guess. We go backwards from the second A, and it's negative.
Yeah, but you always go backwards from the starting point, from the x-axis.
Right.
We start from there. So the fourth way is -5 pi over 6, and then -2. So there are 4 ways to get to the same place. I mean, when you're in school, there's multiple ways to get to the classroom from wherever you're at.
Right.
It's like, which is best? That's a different question, but there are 4 ways to get to every point on the unit circle.
Got you.
So what you should notice here is that 2 of them have positive, what are called R values. 2 of them have negative R values.
Right.
There's always 2 positive angles, and there's always 2 negative angles.
Oh, okay.
Okay, so we should look at just to like really see if this makes sense. We should look at a different angle altogether, somewhere totally different on the unit circle. So let's go 2 pi over 3.
Mm-hmm.
And let's go we'll go positive 3. So you want to be able to come up with other ways to get to the same place. And I would start by going backwards.
Why backwards first?
It doesn't matter, but that keeps the 3. So if you don't like
so
that,
so then it's still positive and the others are still.
yeah, so this one's the positive number, the positive R, and then you've got a negative angle.
Got you.
Something like that.
Okay.
But then the next ones, to get to the next ones, I'll call this B for the moment. The next ones, you have to almost draw the other position, which is just along the same line. And then you have choices, but you can go positive angle to get there.
Mm-hmm.
Okay, and then you got to know where that is. So it ends up being 4 pi over 3. Wait a second. Why isn't that's not right?
That doesn't look right at all.
It's 5 pi over 3. Thank you.
Ah,
That's not right. So 5 pi over 3, but then you're over here in quadrant 4. So to get back to quadrant 2, that's why you negate the R. The R, that means you go backwards, or you flip backwards, or walking backwards to the other B.
Gotcha.
And then the last one here is just this smaller angle minus pi over 3. But then you also need to go backwards to get to B. Now, maybe I'm over, maybe I'm like going a little extreme here. Maybe your teacher won't ask you this, but I think that was a reasonable thing for you to ask me, is like, well, why would you do it this way? Well, it's just, there's multiple ways to get to the same place.
Thank you. That helped a lot.
Okay, so let's go to, we did not do a couple of these. We didn't do 2. I know we didn't do 2. So let's do the rest of these on your list here, and then we'll see what else we can cover tonight. All right, so let's look at number 2. So again, you start by going to wherever that angle is, minus pi over 6. And that's over here in the 4th quadrant. But the -2 tells you that instead of being there, wherever that point is, you have to now go the other direction the same amount. It's like a flip over a mirror. So this is -2 comma minus pi over 6. But as we talked about, there's a number of other ways to get to that, but we're not going to worry. We're not going to focus on that. You can tell me later on for a test or quiz if we need to review that again.
Okay.
All right. So I know we did 3. Did we 4? We did 5. Have we done 6?
I do not believe so, no.
Okay. So let's do 6. All right, so 6, again, just draw your unit circle, locate that angle on the unit circle. So it's in quadrant 2. But the negative of it, the negative means that instead of being there, you're going to go the other direction
in quadrant 4.
In quadrant 4. Now you don't have to figure out where it is, you just have to write. You just have to denote where it is. It's, I guess it's letter D.
Okay, yeah, that would make sense.
Great. So that's polar, that's graphing a polar point. Okay, because there are polar equations that you may have to graph at a later time, but we're not doing that quite yet.
Not yet, no.
Not yet.
Thankfully.
Yeah. So then 9 through 20 are actually this. I'm sorry, 9 and 10 are actually the same. So I guess we can look at those. You said 1 through 10?
Yes.
Okay. So for number 9, you're just in degrees instead of radians. All right, so it's like, where is 90 degrees on the unit circle? It's right there. So 3 just means you're going straight up 3 units.
Okay. Wait, going straight up? Why?
90 degrees is straight up.
Oh, right.
Pi over 2, straight up.
Right, okay, so that would make sense. Okay.
And then the last one here, 4 comma 270 degrees.
Also on the line, so it'd be 4 straight down, right?
Yeah. It's a little weird, but you rotate first, 270, so you know which way you're pointing. And then you go down.
Huh. Thank you.
Anything unclear about that, or anything you'd like some more?
Yeah. Oh my God. Can you actually go over 11 instead? Because I was more worried about the polar coordinates, but I didn't know how to like do it if it wasn't a like unit circle value.
So they have to be all unit circle values. So the next one just doesn't look like it is, but it is. It's 0 degrees. They just didn't put the degree symbol on there.
Oh, you're right, huh?
So normally it's like, all right, 0 degrees, boom, right there. I don't rotate, but then I'm going the other direction -2. So I'm going back over here.
Hmm. Okay,
Because
yeah, that makes sense. Okay, thank you.
awesome.
Then no, I don't have any questions.
Okay, so just give me some more information here. So this is this like you had class and this is your homework assignment, or is it like do you have like the next homework assignment? Do you know what you're gonna be working on next?
Um Actually, yes and no.
Okay.
He gave us two assignments today, and this was one of them. This was like half of one of the things. The other one was like all graphing.
Have you already done
Um,
that, or do you have is that something you could send over?
that is something I can send over, but I don't have the paper. I left the paper upstairs, so I'd have to get
Yeah,
that.
it's probably worth it to spend 2 minutes going grabbing it, and that way we can work on stuff you want to work on. Um, if you're willing to go grab it.
Yeah, yeah. I'll let me
Just let
send this over real quick, and then I'll
Okay,
get the paper.
sounds good.
And here. It's like problems 1 through 11.
But on a different page.
Yeah, on a different page.
Okay, yeah, go ahead and send that over and I'll take a look at it.
All right, I'm gonna go get my graphing paper.
Okay.
I'm back.
All right, excellent. Yeah, so I got
Um,
these. Go ahead.
so before we start, I do remember him saying that this was the harder of the two, and said
Yes.
that this one was optional.
Yeah, but you probably get some of these on your test. I mean, I would think. So you don't. But we should
Yeah,
talk about it. I mean, you're going to take more math. You're going to need to know this. This comes back again in calculus too. Um, so it's worth knowing, in my opinion, and calculus 3, I guess, if you're going into engineering.
right.
Okay, so the first problem, it says R equals 4, but even before that, it says transform each polar equation into rectangular. Okay, so that in class today, you probably, or whenever you last had class, you probably were given some equations like x equals r cosine theta, y equals r sine theta.
Mhm.
And then you were probably told that tangent of theta equals y over r. And then maybe you were told x plus squared plus y squared equals r squared. Does that all look familiar?
I was told three of those. For tangent, he said y over x
Sorry, y over
instead of.
x. Sorry, I meant yeah, typo.
Well,
Okay.
then yes.
Yeah. Okay, perfect. So like this is really hard for students. Like the conversion from one space to another is very difficult. You're supposed to write the equation in rectangular coordinates. All right.
Mhm.
So like, what does that mean? Well, it means that you need to figure out which of these equations to use. Okay. Now, since you're just given R, and this is me kind of guiding you towards the answer, use this last one. X squared plus Y squared equals 4 squared.
I see.
Okay. And so you can simplify here. But what this is, this is a circle with radius 4 centered at the origin. Now, how did I know that? Well, you're supposed to know that too, because you previously took a course in probably geometry where they covered this. Does that at all look like something you might have seen before?
Yes.
Yeah. So in this problem, H and K are 0. That's why it's centered at the origin.
H and K are 0.
Well, they're not present in this problem. X squared is if H is 0, it becomes X minus 0 squared, which is X squared.
Right.
K is 0, it becomes Y squared. So that like that's all sort of like hidden in this problem that you're supposed to like remember or recall. I'm not saying that's easy, but that's the intent here. Like when you
Okay.
see something in this form, you're supposed to be like, circle.
Right.
That's the
Yeah.
expectation. And then it's generally centered at the origin. So you're going up 4 from the origin, right 4 from the origin, left 4 from the origin, down 4 from the origin. So you just some sort of a circle like that.
Okay.
Any questions on that?
No, sir.
Okay. So I would prefer like a written explanation here. I know it says to identify, but I would rather you say it's a circle. It's a circle with radius 4. Like to me, that tells me that you understand what this thing is, centered at the origin, but I'll take circle with radius 4.
Okay.
Okay. So number two is just like number 1. All right. So let's go back and look at it. Grab number 2 here. So this says R equals 2. X squared plus Y squared equals R squared. So this means that the radius is 2. So he's telling the problem is saying, okay, R is 2. It's a circle with radius 2 centered at the origin. Circle, radius 2 centered at the origin.
Okay.
So what does a graph of that look like? Well, from the origin, you go out 2 places, and then you try your best to make it look like a really nice smooth circle.
Okay. Yeah.
So what, like if you were doing a Quizlet on this, do you ever do Quizlets? Do you ever, you know what I'm talking
Yeah.
about? I say that. So the Quizlet here is like R equals 2, circle radius 2 centered at the origin. You have to know you have to know the mapping like from here to here. So that when you see a problem that says R equals 5, you're like, oh, that's a circle with radius 5 centered at the origin.
Right.
You have to know the flip of that card to get that. Any questions on
The
that?
flip.
Well, if you do a Quizlet, I mean, you flip the cards. One way you can do it is flipping the cards. I mean, that's how people my age used to used to actually make 3x5 cards with one side and the other, and you'd flip the card. That's where it comes from. I'm guessing.
Nice.
I mean, I didn't know. But yeah. So because now we're gonna look at the next type. The next type is number 3 here, where it says theta equals pi over 3. And this is like completely different than the last one. So we have x equals r cosine theta, y equals r sine theta. We have tangent theta equals y over r. And I'm sorry, why do I keep doing that? Y over X. Boy, second time tonight I've done that. And then X squared plus Y squared equals R squared. So at a minimum, you should say, okay, Matthew, like I see it's theta. That means it either goes into this one, or goes into this one, or goes into this one.
Right.
And you could guess, but we don't want you to guess. But if you're only given theta, we're going to use the last one. So tangent of theta equals Y over X. We're going to plug that value in for theta.
Okay.
So you have to be able to now know you're on your unit circle. What is the tangent of theta? As a reminder here, it's sine over cosine. So you got to be able to go to your unit circle. I think we talked about this last time a little bit. You got to be able to go to that first quadrant. There's pi over 3. And you need to be able to tell me those values.
Okay. So y would be root 3 over 2 and cosine would, or x would be 1/2.
Yes. Like that, y over x.
Hmm.
Now, can we reduce the left-hand side?
Yes.
Yes, it becomes the bottoms cancel. So it's square root of 3 equals y over x. And if we solve for y,
And then it becomes root 3 over x, or yeah, root 3 times x, right?
yeah, actually that's actually better said. So let me move that and let me move this around. Yeah, it's root 3 times x. Now, as much as you probably don't like this, this is an equation of a line.
Oh, like the mx plus b equals y
Yes,
thing.
yes. And you're supposed to, you can't just say, I forgot it, you do this. So the slope is the square root of 3 over 1 if you want. And then the
Mhm.
b value is 0.
Okay.
So it's literally a line. It's a little hard to draw because it's like, what is the square root of 3? Well, but it goes to the origin. All right. So the square
Right.
root of 3, if you really want to approximate it, if you're really stuck on a number line, the square root of 1 is 1 and the square root of 4 is 2. So it's closer to 2 than it is 1. Like in
Okay.
terms of a number, like if you didn't have a calculator. So it's like, well, that means you're going up like 2 and right 1, but not quite 2. So not
Yeah.
quite 2, not quite 2, not quite, you get a few points here.
Hmm.
Now, interestingly, what do you think this angle is right here?
Not root 3 over, huh? Pi over 3?
Yes.
Oh, because the equation was like
Yes.
theta
Yeah.
equals pi over 3.
Yes. And
Wow.
yeah, I mean, it has to be because that's part. Now, the whole discussion we had earlier about like points on the other side here, they're just
Mhm.
flipped, right? It's still pi over 3. It's just now you're going the other direction.
Hmm. I see.
So you did not have to do all the stuff that we did. Should you? Yeah, you should, but you could shortcut it to this.
Can you say that again? I can shortcut it to what?
You could just draw the okay, so let me give you another problem to show you the shortcut. Let's say I wanted you to graph theta equals pi, make sure it's not the one you're given, pi over 6. So on your unit circle, where is pi over 6?
Over there. Or no, no,
Yeah, right there,
yeah.
right? So it's just that line that goes through those. So I'm done. But I don't have the
Mhm.
equation. That's the problem. I don't have the equation. That's why you have to do it the way we did. I mean,
Right.
you can still, you could tell me what the X and Y values are there, or the tangent values there, but that's the point is to be able to come up with the equation. But that is, this is our line that I've drawn. Okay, so let's do number 4, since you've got to do it, and well, like the way you described it is like you're not going to cover this. And I mean, I would think you would. I mean, it's 5.2. It's not 5.11 in the section or chapter.
Right.
Maybe
He
just meant because
said,
it's what.
sorry, what were you saying?
Yeah, go for it. Tell me what he said.
He said that we might skip around with some of the problems on the test and not do a couple of sections,
Oh,
but I think it'd be good to do it anyway, just in case there's that random one problem.
yeah, I would agree. So whenever it's in this format, theta equals a number.
It's going to be tangent.
Yes. It's another Quizlet, another, this means this. So I need to know it.
Okay.
So you have to put that value for theta in, boom, tangent of minus pi over 4. So you have to figure out, well, where is minus pi over 4 on your unit circle?
Fourth quadrant.
It's down there. There's minus pi over 4. So we need the ordered pair there.
That is root 2 over 2 and root 2 over 2, but they're negative, right?
One of them's negative, one of them is positive. So the x value is positive because you're going to the right, and then the y value is negative because you're going down.
Okay.
So it's y over x, it's minus root 2 over 2 over root 2 over 2.
And then that can reduce to you multiply the twos on both sides of the division sign, right?
Well, they cancel.
Right.
And if you need to, you keep writing it until you can see what it reduces to. This one does reduce nicely. Minus root 2 over root 2. Whenever you have the same thing on the top and the bottom, it always becomes 1.
Right. So it becomes -1.
Yeah.
Interesting.
Yeah. So this is actually gonna be a nice equation of line. So you multiply both sides by x, and you get y equals negative x. Oops, it's kind of in a bad spot. And that's an equation of a line.
Huh.
Right? Y equals mx plus b. Your slope is -1. Your b value is 0. So if we go to try to graph that, start at the origin. Slope of -1 means to go down 1 and then right 1. Down 1, right 1, down 1, right 1, and so on. Then you can go backwards if you want. And you look and you're like, oh, that's minus pi over 4.
Nice.
So from here, they don't get as nice. There's more work to be done to be able to answer these questions. But I mean, you don't have to you're not doing the most complicated ones, but we can look at a couple more here. Any questions though so far?
No, sir, not so far.
All right. Okay, so we got r sine theta equals 4. And again, our options are x equals r cosine theta, y equals r sine theta, tangent of theta, let's see if I can do this correctly, y over x, and then x squared plus y squared equals r squared. Does the thing that's given look like any of these things over here on the right?
It looks like y.
Yeah. So if we just flip it. So what and so what that means is that this part that's boxed in becomes y.
Okay.
Now this is not obvious. And when I say that to you, because if we work together, you'll hear me say that a lot more. It means that until someone tells you, you would have no way to figure this out. You would just sit
That
there and
is,
guess forever. And like, I don't know, that doesn't sound very fair to me, but that's some things in math are like that. So this is not a hard problem now that you know. You're like, oh, it's just y. Yeah, y equals
yeah.
4. But until someone tells you, yeah, you're using one of these when it's in that form, you would just never know. You just, I mean,
Yeah.
you're there forever. Like someone putting like Chinese up in front of me, I'd be like, I don't know, never gonna figure that out without some help.
Mhm.
So what does y equals 4 look like? Hopefully you remember that's a horizontal line.
Right.
Horizontal lines are like looking out onto the horizon. It means in words, and I like the literal words here, it means that y is always 4. Always, always, always 4.
Hmm.
Like that. X can be anything, but y is always 4.
Okay. Okay. Yeah, that makes sense.
So the next few could go pretty fast here now that we know this, but so actually let's do 8 next. 8's the one that's more like it. And this is a good thing to do with your homework, is to kind of look for problems that are like the one you just did.
Mhm.
Because this one is just like it. Y equals r sine theta. So y equals -2.
And the line would be at, y would always be -2.
Y is always -2, yeah.
Hmm.
All right, so we could look at 6 next. Six next here. So again, this is like, you got to know the equations. X equals r cosine theta. Y equals r sine theta. It's good to write them each time you work through this. That way they get committed to memory for that.
Right.
So you can see here that this r cosine theta is really x.
Right.
X equals 4, which is a vertical line. X equals a number is always a vertical line.
Mhm.
X is, oops, sorry, my screen just stopped responding. Technical problem. Come on. Okay, vertical line. And then x is always 4.
Ooh.
So why don't you try number 7? You can either tell me verbally or work it out, but why don't you try number 7?
Um, so number 7 is kind of like number 6, except instead of 4, x equals -2.
That's it. Yeah.
So it would be on the graph you would draw like a normal graph, whatever, and
Mhm.
you move 2 to the left,
Yeah,
and it would be a vertical line going up and down on that point.
that's right. That's perfect.
Awesome. And number 9, I'm a little concerned about
Yeah,
because
I would recommend we not do 9 and 10 with the time we have left, because we won't really get into much of its discussion. I'd like to go back and do a couple of other problems from 5.1. If that's okay with you.
yeah, that's totally fine.
Okay. All right. So they're kind of like what we just did. So let me snip in a problem here, because these are more common with what you'll see. Okay, so here's a polar point, 3 comma pi over 2. Could you tell me, or do it yourself, tell me where this is first of all, and then we'll talk about what this actual problem is. This is just review though.
Um, pi over 2 is the 0, 1, right?
Yes,
So it would be 3 to the right.
up. up because it's once you spin pi over 2, but then you walk out 3 spaces, 1, 2, 3 spaces.
Huh. Okay.
These are like the first 10 that we did today.
Right. Yeah.
Okay. So you're up here. You're literally at the point 0, 3.
Hmm.
All right. Now so the question is, this problem is, how do you go from polar to rectangular? And the answer is those equations that I wrote out. X equals R cosine theta,
Hmm.
Y equals R sine theta. Do you have R and do you have theta?
Yes.
Yes. So your X becomes 3 times cosine pi over 2. Your Y is 3 times sine pi over 2. This is yet another reason why you've got to know your unit circle. You've got to be able to evaluate the cosine pi over 2 and the sine of pi over 2.
Okay.
So on your unit circle, can you tell me the cosine of pi over 2?
On my unit circle, the cosine of pi over 2 would
Yes.
be on the unit circle itself.
Yes.
Cosine would be 0.
0. Yeah. So it's 3 times 0, which is 0, which is what we expected. How about the sine of pi over 2?
Pi over 2 in this sense, or pi over 2 just in general?
No, the unit circle. Unit circle.
1.
1. So it's 3 times 1.
Oh, okay.
So you're going to use these two equations to convert from polar to rectangular.
Okay. Thank you. That
So let's look at one more real quick here. The lessons are 50 minutes, just as a reminder. So we're getting down here to the end. So this new problem here, here's R, here's theta, and we're going to use those formulas again. X equals R cosine theta, 6 times the cosine of 150 degrees. So yet again, you got to know your unit circle. You got to know what the cosine of 150 degrees is. And for me, it doesn't matter to me if you're just looking at it up on the table, but you gotta know that value.
right.
Okay, so you should get 1/2 for that. No, sorry, negative 1/2.
Okay.
And then that reduces to -3. And then Y equals R sine theta, 6 sine 150 degrees.
And the sine is -3 over 2, root 3 over 2.
Yeah, so it becomes -3 root 3. And so that's your ordered pair. So like on your like if this is your unit circle, the 6 150, we know it's over here in quadrant 3. It's one of the, but it's over here. So this point is not drawn to scale, but -3 square root 3.
Okay.
So it's getting to the same place.
Right.
So one's polar, one's rectangular, like that.
I'm sorry. Did this one go from polar or from rectangular to
No.
polar? Or?
Polar to rectangular.
So the rectangular is -3
Yes.
and -3 root 3, right?
Yeah. Yes.
That seems very weird to me, but okay.
Okay. We'll pick up here next time. Hope you have a good Thanksgiving. We'll pick up here next Monday with this or something new. But thanks for letting me help you out, and I'll see you next time.
Yeah, thank you. Have a great
night.
Thanksgiving.
Okay. Bye now.
Bye-bye.